And now with this provider, we can start creating resources in AWS. And the way we create a new resource in AWS is using resource key. And every resource that we have access to through this provider has a specific name. So we need to know the name of the resource to be able to create it. For example, we want to create a VPC in our account in this specific region. The resource name for creating a resource is provider name prefix underscore and the resource name, right? So this is the resource name that we have access to through the provider. So these are the names of all the resources that you can create. So basically, whenever you want to create a new service, a new resource, you can just look it up here, what the name of that resource is. And the second name of the resource is what we decide to give that inside our Terraform. So this is like a variable name, basically. So we can call it whatever we want. Let's say this is our development VPC. And inside the block, we can pass in parameters. So basically, we're creating a resource called AWS VPC. And we're giving it a name inside our Terraform context. This is the name that we decide on. This is the one that AWS provider basically gives us. And inside here, we need to define parameters. For example, for VPC, there is a parameter we need to pass in, which is CIDR block. So basically, we define an IP address range that will be assigned to this VPC. So all the components, EC2 instances, whatever that get created inside that VPC will get an IP address from this IP address range. So this is going to be a private IP address range for that specific VPC. And we can define it to whatever we want. Let's do 10.0.0.0.16. And as I said, CIDR block is basically just an IP address range. And that /16 or number after slash basically represents how many IP addresses will be in that range. So we have 1 to 32. So we can specify here values from 1 all the way to 32. So 32 basically will be just one IP address in that range. And the lower the number, more IP addresses you will get available for that VPC. So how do you decide the CIDR block value? You basically think about how many resources and components you will be creating inside the VPC. And based on that, you know how many IP addresses you will need. I will put a link in the description with CIDR block calculator, so you can basically just check how these values are calculated. And this will create a VPC in our AWS account in region EU West 3 with this IP address range. And again, where did I get this attribute name from? You can look it up inside the documentation. And you also see that you have additional parameters you can pass in. So you can add tags to basically any resource in AWS. And you have a list of all the other attributes you might want to configure in your VPC here as a list, right? CIDR block we just defined, but you also have all these other options. And let's see another example of a resource. For example, what if we wanted to create a subnet inside our VPC? Then we would define another resource, and subnet resource name is AWS subnet. And we can call it some custom name for our Terraform context. And inside that, we can pass in some values. Whenever we are creating a subnet, we need to tell Terraform in which VPC the subnet should be created, because subnet belongs to a VPC, right? It cannot be created outside a VPC. So we need to define which VPC this subnet should be created inside. So the first attribute is going to be VPC ID. And this is an important note here. When we are creating a resource for another resource that doesn't exist yet, right? So basically we want to say create a VPC and then create a subnet inside that VPC, but that doesn't exist yet. So in Terraform, what you can do is you can reference the resources that you have defined in the same context, right? Even though they may not exist yet. So how do we know the VPC ID of the resource that doesn't exist yet? Well, in Terraform, we can do it by referencing the resource that we have defined, dot the name that we have given it. And this is basically going to give us the whole object that will be created. And on that object, we can access the attributes, right? So that's how we can reference an VPC ID of a VPC that we haven't created yet. Then we have some other attributes that we need to define. We have CIDR block. So VPC has this range of CIDR block, right? IP addresses, and subnet will get a sub-range of these whole VPC IP addresses. So we have to define which subset of these IP addresses the subnet will get. And we can define it to be 10, 0, 10, 0. So this is going to be a subset of the IP addresses defined here, and /24. And we can also define in which availability zone in that region this subnet will be created in. If we leave it at default, it's just going to take a random one, but we can also fixate it. So let's say availability zone is EU West 3A. So this region happens to have 3 AZs, so we can choose the first one, which is 3A. So basically this is how you can create a resource that depends on the other resource that we haven't created yet. So by referencing the name of that resource using the resource name that provider gives us, the official name, and the name that we define for that resource. And this will basically give us the whole object, the whole resource with all the attributes. And if we just want one single attribute from them, like ID, we can get it like this and assign it to the attribute. And later I'm going to show you how to know the attribute name of the object that you're going to get in here. And now that we have defined resources that we want to create, how do we actually create them using Terraform? Well, for that, there's a Terraform command called apply that will take whatever we define in this Terraform file, and it will see that there are 2 resources defined that should be created, and then it will apply this configuration. So right now, if I go back to my VPC, I have 3 VPCs, one of them is default. So when we apply this configuration, we should have a 4th one. So I'm gonna go back to terminal and let's do, again, I am inside of that folder of Terraform. And inside that folder, I am gonna execute Terraform apply. And here you see it is waiting for our input. So basically we need to confirm the action that Terraform is going to take. And if we are gonna scroll up, here you see what Terraform plans to do in order to give us this desired state, right? We have defined we want 2 resources, we want a VPC and a subnet inside with these parameters to be created. So Terraform, when we executed apply command, went ahead and calculated in the background what needs to be created to give us this desired state. And we see that list of what Terraform will do listed here for us to review, so to say. So plus is for create. So you see this green plus for something that's getting created. So first of all, we have AWS subnet with this name that will be created and a bunch of attributes of the subnet. Now, some of them we set ourselves, like CIDR block. This is provided by us, as well as AZ. and this is defaults for these two attributes. The rest of them are unknown, like ID, because these attributes will be set once the resource will be created. And a second resource that will be created is VPC. And here you see again all the attributes of VPC, some of them that we set, like CIDR block, some defaults, and the rest of the attributes are undefined. And these are actually the attributes that you can reference inside the config file for other resources. So in our case, we took the ID of the VPC, which is right here, but there are a bunch of other attributes that we could also reference of one specific resource. And obviously, depending on which resource we're creating, of which resource type, which is defined right here, we have a different set of attributes. And here we have a summary. 2 resources will be added, 0 changes, 0 destroys. And if we review this and we think that everything looks fine, we are gonna confirm this with yes. So if we type anything other than yes, basically it means we're not confirming this change. So I'm gonna enter, and now we're seeing output of what Terraform is doing. So VPC got created and subnet got created. And here we see the output of that Terraform apply. And if I go back to my AWS console and refresh it, there you go, we have a 4th VPC, and this is the CIDR block that we configured for it. We didn't give it a name, which is given by tags, so it's empty, and the ID obviously got auto-generated. And if I click inside, we have a bunch of other data about our VPC. So basically all these attributes that were unknown got automatically generated and set by AWS. And I'm gonna copy this ID. And if we go to subnets, this is a subnet inside that VPC that we defined. This is the CIDR block value that we have defined as well to be 10.0.10.0 and a bunch of other data here, which was also automatically generated. And it is in AZ3A, just like we defined. So all of that got applied successfully. Now, what if you wanted to create a subnet in an existing VPC? So basically, you're not creating a new VPC, but you are creating a subnet for an existing VPC. So you would need the ID of an existing VPC. So one way to do that is obviously going to your AWS account and going to your VPCs and then grabbing the ID from here, which is not the most efficient way to do it because you have to go to UI and then navigate to the resource and fetch the ID. So for that, you can also query this kind of information from AWS using the provider. And for that, there is another component that provider gives us in addition to resource, and it's called data. So data basically lets you query the existing resources and components from AWS, while resource lets you create new resources, right? So these are the 2 types of components that you get from a provider, and you can also find the data documentation in Terraform. So if we go back to, let's actually look for EC2, for example. So right here, you see we have a list of resources, and if I close it, you see data resources. So Terraform provider gives you access to resources and data, like you see in these examples as well, for all the providers, not just AWS. And in data resources, let's go back to VPC. And VPC, you also have resources and data resources, and they are actually named in a similar way. You have the prefix of provider and then the resource name. And if we scroll all the way down, here you have AWS VPC. And inside that, you have a documentation of all the attributes you can use. So let's define a data here. It's called AWS VPC. Let's call it existing VPC. And as a parameter, we are passing in a search criteria, right? Or filter criteria. So we basically want to tell AWS, give me a VPC that matches these following criteria. So here we are going to pass parameters that will tell Terraform which VPC we want to get here as a result. And if we go back, we have a bunch of parameters here. We can tell Terraform, give me an AWS VPC that has this specific CIDR block, or give me a default VPC, or give me a VPC with this specific ID if I know the ID, for example, or a VPC that has a specific key value pair defined. And if we want something more advanced, then we have a filter attribute here that lets us define some more custom criteria to fetch the VPC. And this basically applies to all the resources whenever we're defining data of a provider. If it's AWS or some other provider, we can fetch some information, some resources using the data. So let's say in our case, we want to get a default VPC. So default is true. And we want to create a subnet in that existing VPC. So the way we do that is we're gonna remove it. And instead here, we're gonna define the VPC ID of a result of this query. And the way we reference data component and results of this query is using data and then name of the data, the name that we defined for this data. And again, this will give us the whole object. We just want the ID. So we're gonna access the ID attribute. So the difference here is basically that if we're using and referencing a data result or data query result, we are using data at the beginning. So Terraform knows that this name comes from a data and not a resource. And of course, we will need to change the name here because it has to be different. So we can call it dev subnet 2 because it's the same resource. So we have to give it a different name. And another thing we need to fix is the CIDR block because we're creating this subnet in a default VPC. So we need to provide here a subset of IP addresses from the default VPC's CIDR block. So if I go back to my AWS management console, this is the VPC, the default VPC, and this is the IP address range that this default VPC has available. So this is the CIDR block that we assigned our VPC. This is the one from default VPC that got assigned automatically. So we are gonna need this range. However, the default VPC has subnets that also get created by default in a region by AWS. And these are the subnets. And obviously each subnet inside a VPC has to have a different set of IP addresses, right? The range should not overlap. So we're gonna need to choose a subnet range that is not assigned to one of the existing subnets in that VPC. So we're gonna take the next range for our subnet. So I'm gonna copy the last one here and we're gonna just take the next subset. So it's gonna be 48.0 and we're creating it in the first AZ. So again, VPC gets an IP address range and the subnets inside that VPC can have subset of the IP addresses that VPC itself has available, right? So we cannot assign it something else or a range outside of what VPC has. And also it should be different from what other subnets inside that VPC have. So this should work. And now that we have our dev subnet 2 configuration ready, let's apply that using Terraform apply. And Terraform is now again going to calculate the difference and the actions it needs to take in order to fulfill our desired state. So everything inside this main TF file, and this is what it came up with. So basically one resource, dev subnet 2, is going to be created with all these attributes, and we are going to confirm it. And as you saw, we have 3 subnets inside. We're creating a 4th one. So let's apply. And as you see, apply complete, subnet got successfully created. Let's refresh. And there you go. This is our new subnet. And this is the IP address range from the VPC. And as you see, Terraform syntax is very straightforward, very intuitive. And what's more important, it is very consistent. So no matter which provider you use, no matter how you access the components in that provider, you have a very consistent syntax. One way that I like to describe provider and resource and data is that similar to when you're programming in any programming language, provider definition is like importing a library that has a set of code and functions, and defining resource or data is basically like calling a function from that library that you just imported by passing in various parameters in that function. And resource is basically a function that creates something. A data is a function that returns something that already exists. And of course, the user credentials that are defined here, or the user that these credentials belong to, has to have permission, obviously, to create those resources or to query the resources with data. So keep that in mind. Now we have all this configuration defined here. So what happens now if I execute Terraform apply again? So let's go back to the console, and I'm gonna do Terraform apply. And you see that Terraform basically just checked all the resources. You see refreshing state output here per resource that we have defined. We have the VPC and the 2 subnets, and Terraform decided there is no changes that need to be made here. And the reason is that Terraform language is actually declarative. So what does it mean? We basically declare what we need the end result to be. So we're not telling Terraform what to do. We're not telling it to create a VPC and create a subnet. We're telling Terraform, I want 1 VPC with this configuration, and I want 2 subnets. And we're just defining or declaring all this configuration here. And then when we do Terraform apply, Terraform needs to figure out the current state in the AWS account. So do we already have 1 subnet with this name and with this configuration, another subnet with this name, this configuration? If yes, Terraform knows there is nothing to do. If Terraform cannot find the subnets in the AWS account or this VPC, then Terraform knows it has to create one. So that's an important characteristic of Terraform. And it has actually a lot of advantages, one of them being the idempotency. Idempotency basically is a fancy word that means that whenever you execute or apply the same exact configuration 100 times, you always get the same result, right? Which is a good thing because you won't break something accidentally. And also you don't have to, as a user, you don't have to remember and know what the current state is and define what changes need to be made to that state. You only have to define what your end desired state should be, the end configuration should be, how many subnets you want, which subnets you want, how many VPC, which VPC configuration, and Terraform makes the necessary changes to get you that desired outcome.